Hello and welcome to CSE 350 Digital Electronics and Pulse Techniques course offered by BRAC University in the UX platform. This is your first lecture. In this course, we are going to make bridge between the abstract world of digital logic system and the circuit and electronics theory. Our main goal is to build a foundation for our students to make better understanding of the basic digital systems, which is heavily dependent on electronic circuitry. Moreover, we are also going to explore the essential part of digital communication and storage method, that is electrical pulse techniques. This course is designed from a bottom-up approach. That means we are going to discuss the inner working of digital logic devices by means of our understanding of circuit and electronics. The prerequisites needed for this course are the knowledge of digital logic design, and basics of circuit and electronics. But if you have forgotten the lessons from these courses, you do not need to worry. We will be covering the essential part of these courses in order to make this course self-contained and understandable for everyone. So, let's begin our journey. This course is divided into two obvious sections. One is digital electronics and another one is pulse techniques. In the earlier part of this course, we are going to cover digital electronics section. This part may last around 14 to 15 lectures. Before midterm we most likely be at end of the digital electronics section. And in the later part of the course, we will be discussing the pulse technique methods. In the final exam, you might get about half of the questions from digital electronics and other half from pulse techniques. The marks distribution and grading policy are going to be posted on the course homepage later. If you have any query regarding these, you are welcome to discuss in the discussion forum. Furthermore, if you have any question related to a specific lecture video or homework problem, then you might post that question in the discussion section, at the bottom of the page of that video or homework. Today we are going to give you a brief overview about these subjects, and what topics you are going to encounter in this course. First, we are going to discuss briefly about digital electronics. As you all know, digital systems are the engine that drives the information age, letting us reliably store, communicate, and manipulate incredible amount of information each day. In order to know how digital systems works, it is essential to learn the basic principles of digital electronics. This is a field of electronic involving the study of digital signals, and engineering of the devices that produce them. Here by digital signal we mean the physical representation of abstract binary data, containing just ones and zeros. There is very important distinction between analog and digital electronics. Analog electronics is required for processing analog signals. But in this new era, we are using digital devices for the signal processing. So, in order to process real-life analog data, we require analog to digital conversion as well digital to analog conversion. Moreover, digital electronics is the foundation of the modern computers and digital communications. Therefore, there is a worldwide demand for engineers in the design of consumer, industrial electronics, communication, and embedded systems, computer security to military equipment. Furthermore, devices that are used in the application are constantly decreasing in size and employing more complex technology. It is therefore essential for engineering students to understand the fundamentals, implementation and application of digital electronics, devices and integrated circuits. In order to survive and flourish in the cutthroat competition in today's market economy, this knowledge will help you to realize the most effective methods to suit your technical need. Now let's discuss the pulse techniques. What is a pulse in our context? To put it in simple words, a pulse is a burst of current, voltage or electromagnetic field energy. Electromagnetic field refers to a physical field produced by electrically charged objects. But our discussion will mainly be confined only to voltage or current. Electrical pulse is essential for digital communication. For example, the internet data you are using now are transmitted from a web server through optical fibers, which contain digital data in electrical pulse form. This pulse is reinterpreted in your Wi-Fi module or mobile network service station, and those pulses are again put in the form of electromagnetic wave. This pulse waveform is picked up by your smartphone or laptop, and that device displays the signal to you in the intended format. The digital pulse we are talking about comprises brief bursts of DC current or voltage, with each burst having an abrupt beginning and an abrupt ending. This pulse shape is ideal for digital communications. But in real-world scenario, this is little different. The electrical pulses in real world get distorted, deformed due to noise and interference. So, we need to engineer these electrical pulses in such a way that, despite encountering those noise or interferences, we can retrieve the original message accurately from the user end. That's why, the pulse technique is important for digital communication as well for digital systems. So, pulse techniques consist of generation of different types of electrical pulse shaping techniques, and electrical pulse transformation techniques. In order to generate electrical pulse for transmission we need to build special circuitry, and detection processes also require sophisticated circuits, with both digital and analog electronic components. Pulse shaping is done to mainly recover the pulse signal form, from the distortion while transmission and reception. Hence, pulse techniques are essential for realizing the interconnected digital system with digital networks. That's why, it is imperative for computer science and engineering students to understand the underlying methods and principles of pulse techniques. Let's take a short overview of this course. From digital electronics side, we are going to cover different digital logic families. These logic families signify how digital logic gates are realized using different electronic devices such as diode, transistor, and MOSFET. In this course we are going to learn how to design these logic gates, using those electronic devices. This design process requires a significant mastery over the principles of circuit and electronics. For that reason alone, we are going to review circuit and electronics early in this course. Here we are going to introduce you to some basic electronic circuits and analyze as well as compare the performances between them. By these comparisons, you are going to learn which type of design is suitable for which application. Now on the pulse technique side, we are going to start with digital to analog converter and analog to digital converter. These are the essential part of any digital system, when that system has an analog interface with the real world. Next, we are going to discuss about multivibrators like monostable, bistable and ashtable multivibrators. Almost all digital devices are synchronized to a single clock frequency for appropriate application. These multivibrators are important components of generation and manipulation of those pulse frequencies. Furthermore, these devices can be used to make detection devices and pulse transformers as well. Finally, in this course we are going to learn how to generate different pulse waves, like triangular, square, sawtooth waves. By learning them, you will have a better understanding of the operation of oscillators, feedback loop and many other pulse technique methods. In this course, we are going to use several textbooks for different topics. In each lecture, we will provide the necessary resources and references for that particular lesson. In this course webpage, we are going to upload important chapters from the above-mentioned books. But while we are reviewing circuit and electronics, you can refresh your knowledge by reviewing any circuit and electronics textbook you want. But we will be discussing only those topics that are required for this course only. These review lectures are going to be referred in future, when we will be studying our original course content. Then you can come back to these lectures and get a quick refresher about these materials. So, these reviews are very important for you to brush up your knowledge about circuit and electronic devices. Now let's take a look. What are we going to review in these early lectures? At first, we are going to discuss basic terminologies related to electrical circuit, for example the definition of branch, node, loop etc. We will be discussing as well the basic circuit laws, like Ohm's law, Kirchhoff's law, and we are going to focus particularly on nodal analysis. Now you might ask yourself, what about the other methods and theorems? Those are important, but in order to understand this course well, we mainly require nodal analysis. If other methods are going to pop up in future, we will take a short detour and discuss those topics there. Now from the electronic devices side, we will introduce you to the basic model of diode, bipolar junction transistor or BJT and CMOS devices. Our circuit models are going to be as simple as possible but not so simple that misrepresents the physical model completely. Finally, we will end our review section by teaching you DC analysis techniques of these electronic devices.